In this video, we're going to review the rules for rational exponents. Now, when I say rational, you should be thinking, the exponent is a fraction. That's what she's saying. The exponent is a fraction. And this is when the exponent is an integer. In other words, a whole number greater than or equal to 2. So it's a 2 or 3 or 4 or 5 or 6, etc. Okay, so here's the first rule. And the rules show you, these two rules will show you how to change a rational exponent, in other words, a fractional exponent, into a radical. Okay, this is only when the n value is greater than or equal to 2. So if we have a base a raised to 1 over n, and n is a number equal to 2 or larger, that is the same as the nth root of a. Now you know this, you've seen this before. A to the 1/nth power is the same as the nth root of a. And along the same lines, if you have a raised to the m over n power, that is the same as the nth root of a to the m power, the power being under the radical, or you could write it as the nth root of a to the m power outside of the radical. Those are equal. That's the same thing. And this works when you have the exponent m over n simplified. And of course, it has to be positive. If it's not, you're going to have to flip the thing upside down to make it positive. We'll see that in an example we're going to work out below. Okay, so let's do an application of these rules for fractional exponents. The instructions here are write these guys as radicals. So we're going to write fractional exponents as radicals. First, we have 16 to the 1/2 power. Okay, 16 to the 1/2 power, then the next one's going to be 12 to the 1/2 power. Then we have base negative 81 in parentheses raised to the 1/3 power. Then we have 8 raised to the 2/3 power. Oh, well, before we go to that one, let's actually work the first one, a. 16 to the 1/2 power can be written as the square root of 16. See, there's a little 2 in that hook, but it's invisible. We don't see the 2's. So the square root of 16 is 4, because 4 squared is 16. Okay, 12 to the 1/2 power, that is equal to the square root of 12. Now let's simplify the square root of 12. Bust out the perfect square factor, the square root of 4 times the square root of 3. That's legal because 4 times 3 is 12. Now simplify the square root of the perfect square 4, and you get the answer 2 times the square root of 3. Now, negative 81 base raised to the 1/3 power is equal to, according to our rules, it's equal to the cube root of negative 81. Do you see that? The 3 was in the denominator, so that became the index in our root, the cube root, the third root, and then the parenthesis contained the base, negative 81. That became our radicand, that one under the radical sign. So we had the third root, or the cube root, of negative 81. Now, there is a perfect cube embedded in negative 81. It's negative 27, so let's pull that apart. The cube root of negative 27 times what remains is the cube root of 3, and that's because negative 27 times 3 is negative 81. And now we can simplify the first factor. Cube root of negative 27 is negative 3. You can check that to make sure it's true. So our final answer is negative 3 times the cube root of 3. Okay, let's do some more. Those first three, a, b, and c, they applied to the first rule, a to the 1 over n equals the nth root of a. Now let's do some examples that apply to the second rule, a to the m over n can be written as a radical nth root of a to the m, or the nth root of a in parentheses raised to the m. So first we'll work with, part D, base 8 raised to the 2/3 power. Okay, and part E, 16 raised to the negative 3 over 2 power. And part F, 8 over 27 raised to the negative 2/3 power. Okay, back to part D. We have 8 squared to the 1/3 power. Do you see what I did? I wrote that as 8 squared to the 1/3 power. Instead of going directly and applying the rule, I'm going to do it step by step. Now, you can just apply the rule if you understand it, but I'm going to do it in a way that seems logical to me. I can write 8 to the 2/3 power. I can decompose that to 8 squared parenthesis to the 1/3 power because it's the same value. Now, I can change the 8 squared to 64. So we have 64 to the 1/3 power, and now I use the rule. This is actually the first rule, cube root of 64. And I know the cube root of 64 is equal to 4 because 4 to the 3rd power is 64. Okay, now the second, part E, 16 to the negative 3/2 is messed up because it's got a negative exponent. So my first step is to rewrite that as 1 over 16 to the positive 3/2 power. Now, and I could just directly apply the rule here. Let's see. Or I could take it slowly and write it as 16 to the 1/2 power and then raised to the 3rd power. And then write the 1/2 power as the square root of 16 to the 3rd power. And that's 1 over, evaluate the square root of 16, that's 4 to the 3rd power. But 4 to the 3rd power, 4 times 4 times 4 in the denominator, that gives us 1 over 64. And finally, 8 over 27 to the negative 2/3. That's equal to, all right, I want to get the exponent positive. So I'm just going to flip the base, 8 over 27, to 27 over 8, and that changes the sign of the exponent from negative 2/3 to positive 2/3. That's the rules of exponents. That's how you change a fraction raised to a negative power to a fraction raised to the positive power. You just flip the base fraction, and that changes the sign on the exponent. Now I'm going to apply the 2/3 power to the top and the bottom. All right. So first, a little reminder here. How did I do this? A over b to the n is the same as b over a to the minus n. That's the rules of exponents. Okay, so we've got that. Now let's apply the 2/3 power to the top and to the bottom. Okay, so on the top we have the cube root of 27, all raised to the 2nd power. On the bottom we have the cube root of 8, all raised to the 2nd power. Okay, the cube root of 27 is 3, and the cube root of 8 is 2. So we have 3 to the 2nd on top and 2 to the 2nd on the bottom, and then we evaluate that, and we end up with 9 on the top over 4 on the bottom.